Hello everyone, and welcome to the first video in a series about data science. I will be covering practical applications of analytics, programming, machine learning, and deep learning, with examples that you can use to learn and apply to your own use cases. In this first video, I will give an overview of what data science is, what a typical workflow might look like, and then briefly talk about the tools and technologies that a data scientist might use. I will also show two examples of the types of questions a data scientist can answer by leveraging analytics and machine learning. So, what is data science? Companies collect data for various reasons, be it to monitor performance, finances, compliance, etc. They then use this data to inform their decision making. With today's technology, companies can collect huge amounts of data. However, before the data can be useful, they must be analyzed for trends, patterns, and relationships. The following is the typical data science workflow. Data comes from taking measurements in the real world, and like we said previously, companies have various reasons for collecting data. These data are stored in databases. A data scientist first understands the problem or question they are trying to solve and finds the relevant data in the databases or even finds supplementary data in external sources. The data are then cleaned and organized in a manner that makes it suitable for analysis. This may involve filling in missing values, standardizing numbers, filtering for a specific date range, etc. How the data are cleaned depends on the type of problem. After the data are cleaned, analysis is performed to uncover insights that may help answer the question or solve the problem. If the only thing needed was to answer a question, the analysis may end here, and a report or dashboard is built to communicate these findings. But if the goal is to automate decisions or make real-time predictions, a data scientist may build a machine learning model or deep learning model to use within an application. The following are typical tools and technology a data scientist might use. Python is the most popular programming language for data science, and has a simple syntax and rich ecosystem. Many of the most popular data science libraries are built using Python. Scikit-learn is a Python machine learning library that contains several machine learning algorithms and works well with other Python libraries such as NumPy and Pandas. Pandas is a library for working with data in tabular format. It contains many functions for data cleaning and organization. GitHub is a platform that uses Git to provide version control for controlling and keeping track of modifications to your code. PyTorch and TensorFlow are deep learning libraries for creating and training deep neural networks. These can handle tasks like image classification and text generation. Some flavor of a SQL database for storing large amounts of data. PySpark is a Python API for Spark, which is a distributed computing framework. Sometimes the data we work with are so large they do not fit into the memory of a single computer. So we distribute the work across many computers to allow us to do large-scale analysis. And finally, we have Microsoft Excel and Power BI. Excel is a very ubiquitous common ground for technical and non-technical people, and sometimes to communicate our findings, we need to see the data in a familiar environment. Power BI is for creating dashboards and interactive visuals that can help empower others to interact with the data and for us to communicate our findings. Next, we will walk through two examples to show you the type of problem or questions a data scientist can be expected to answer. For the purposes of this demo, I have created the following data. But let's suppose we're working with some retail data. The marketing team wants to understand customer behavior better, especially how much customers typically spend and how satisfied they are with their purchases. We've been handed a dataset with two key metrics: dollars spent, which is the total amount a customer has spent in store or online over a year, and then average review, which is the average review rating a customer has given across the products they've purchased. You can see the dataset has two numeric fields. To understand the relationship between these two fields, we can use a scatter plot. From just plotting the data, we can already see two main groups: low spending customers who do not seem very satisfied, and the moderate to high spending customers who are more satisfied. we can already start to imagine that maybe the more affordable products are not as higher quality, or the customer shopping experience is deterring them from making more purchases and giving the company bad reviews. We've just eyeballed the data, but let's dig deeper using a more scientific approach and segment these customers into groups. The following is an algorithm called k-means, which is for creating these groups based on the distance the points have to one another. I have chosen here to create 3 groups. K-means also requires the data be standardized, which is a type of pre-processing step. After creating the clusters, we can plot the data again, but this time the data points are colored by the cluster they belong to. We have the big spenders who love the brand, budget shoppers who aren't thrilled, and then the in-between customers who might be persuaded to spend more. Imagine how powerful this insight could be. The business could tailor targeted marketing, personalize discount offers, or improve service to turn passive shoppers into loyal ones. For this second example, suppose we're working with a zoologist who has thousands of images from wildlife reserves. These images include images of mammals, birds, and reptiles, but they're not labeled, and manually sorting through them would take weeks. The zoologist asks you to build a model that can automatically classify each image into one of the 3 categories. With image classification, we can train a model to recognize patterns like feathers, furs, and scales, and help the zoologist quickly analyze biodiversity, track species activity, and even detect unusual sightings in real time. So to showcase how this model works, we'll upload an image, and the model will detect and classify that this image is a mammal, and even give you back a confidence or probability score. Thank you for watching my video. I hope you've learned a little bit of what data science is and the types of questions it can answer, and I'll see you in the next one.